Welcome, everybody. My name is Patrick Webb, and um, wanted to present to you techniques that I've learned to do CNC routing in my garage with kind of the maker community CNC capabilities that are out there. Um, Titled this Precision Aluminum CNC Routing in Your Garage. There's a lot of routing going on in people's garage, and I'm focused on building an aircraft. So this is around this. These techniques will apply to working with aluminum and other soft metals. But it's a presentation that I gave at Oshkosh, um, the air show in Wisconsin, and it was actually titled "Scratch Building with a CNC Router." So scratch building experimental aircraft. So we'll be focused around looking at drawing some aircraft parts and then um, speeds and feeds and techniques on making that with precision in your garage. Um, and doing that without making a big mess, without lubrication, trying to make a repeatable techniques. My website, scratchbuild.net, is a journal of um, my aircraft construction process. So we've got lots of other metalworking type techniques there. It's right now getting overhauled, so some of it's a little outdated right now, but it should be overhauled here in the October November timeframe of this year. So um, this is a pretty decent long video, but there's a lot of I'm going to walk through kind of step by step on how to create these parts, how to do mill these parts. We'll go over the software and hardware tools. We'll do step-by-step instructions. I'm going to show some videos of the techniques so you can get an idea of what things will look like in your garage if you were to try to replicate this. Um, I'll share what I know about CNC settings that I've learned. Um, uh, I've learned from others as well as from just going through the process here. And I'll certainly provide links to these settings, like files for the CAD program, so that you can bring in a CAM program, so you can bring in these speeds and feeds if you want. Links to the specific videos that are embedded in this, since this is a pretty long course, so you can just go back and look at videos if you like, that sort of thing. So the first video here, this part one, we'll go over kind of general techniques, and we'll go through thin aluminum parts to even thick aluminum parts like 3/16 inch thick aluminum, the differences in the techniques. And then the second, I'm going to break into a second video, the some advanced techniques for making really large parts that are bigger than your CNC router that you might have in your house. I'll detail making one of the skins for the aircraft, which is about 10 feet long by 3 feet, 2 or 3 feet wide. Both of these parts were included in the same session at Oshkosh, but I'm going to break the videos up a little bit here because not everybody might be making very large metal parts. So that'll be the second video. It's 3D printers have come an extremely long way. This is showing, they once used just for commercial purposes for prototyping and design, large, expensive technology. And as everybody knows, 3D printers have now gotten to be economical and feasible to put in schools and even your homes because the prices have come down drastically. Large community around that. Well, for those of you that are brand new to what CNC routing is, it's basically the opposite of a 3D printer. CNC routing is instead of building up a part, you're carving away material and reducing material down to a new part. So this is showing a commercial CNC router. These have been used for decades in manufacturing for all sorts of parts that go into all sorts of devices. And these have actually, there's a whole community of folks that have made CNC routers that you can build now, build or buy complete, that are economical for your home. This is showing a CNC router that you can get plans for and construct this whole thing by yourself. Make the parts and and build your own machine at your house. Um, and so there's a variety of different options out there to get a CNC router for your house that you can use in your own shop. Let me go over some of the basic. Uh, Again, some of this may be really basic for some, but for those of you brand new to what a CNC router is, um, if we take a look at this machine, first you have this red device in the middle pictured here is a router. It's very similar to a drill, but it runs at a faster speed, a faster RPM. A cordless drill or a drill press might run from a few hundred RPM to maybe a couple thousand RPMs, rotations per minute. A router will run in the range of tens of thousands of RPM, so it's running much faster. Um, you don't typically do drilling; they're meant for cutting away and routing. So what you see here is a router bit attached, and it looks kind of like a drill bit, except that you'll notice that the tip it's flat, so it doesn't have a pitch to the tip to drill into material. And you can still drill, just very slowly. You have to kind of use a technique. You may there's different techniques, maybe depending on the material you're going into. But the idea is that once you get it on top of a surface, that you just start cutting away a little bit at a time instead of going straight down to the material. But you can use drill bits on these. You can use different types of bits. Routers are pretty common for all sorts of wood making techniques. Any of your cabinetry in your house, your furniture, certainly a router was used at some point to maybe not a handheld router like this, but a table router was used to uh, cut the bevels and patterns in your material. So they're very common, easy to find tools at your hardware store basically. Uh, Handheld routers like this are 50 to 150 $150, something like that. So you've got the bit here that's going to rotate, right, just like a drill. And you can typically control the speed like a drill. You can control it from 15,000 RPMs to 30,000 RPMs, so it's going really fast. And then the CNC, this router is mounted on the CNC, right? So and you can move that control it in three different axes with the computer, right? So or by hand. Um, so first you may have, here we're showing X movement. So if you're moving the router back and forth like this, that might be the X axis. And sometimes you can, uh, tell, configure your machine, which axis is X, which one is Y. Here's the Y axis. And then of course the Z axis would be up and down motion. So you have three axes that you can control the movement of this machine. So, and you can control how fast it's moving in any one of these axes. And a lot of programs will allow you don't have to move just one axis at a time. You may be moving in a 3D path that might move on multiple axes on the same time. So whatever your software can do in terms of drawing a path for your tool to go, and we'll go through that. You can move around these three axes at the same time. Those are there are other CNC routers that might have more axis of movement. This is a 3-axis CNC router, most common configuration, what you probably would be able to build in your garage, have in your garage. Commercial products, there may be more where you have more motions of where you can actually maybe tilt the router at different angles, right, to get a little more fancy on what you can do. Those are the basics of what a CNC router is now. So how do you go from it can seem a little overwhelming at first. How the heck do I get my idea or drawing and get it made into a part? It's really kind of a 3-step process that we'll walk through. First you're going to draw whatever you're going to make with some sort of computer-aided design package, some sort of CAD package. That's when you hear CAD, computer-aided design. So we'll go through that. I'll show you the package that I use, and there's a lot of options out there, of course, for all of these tools. And then after you draw the part, then you're going to create the tool path. Where do I want that router to actually go? I've drawn my part in, kind of in a scale model of my part. Where are you going to make that router go? And you're going to use a CAM package for that, computer-aided manufacturing. So this is, it kind of knows the diameter of the bit so it knows where to kind of put the router away from the part to cut it properly. So we'll review how to use that package, that type of software. And then once you've got those tool paths, you're going to get this file that you're going to have to load into your machine basically to make it go and do and make the part. So really kind of those three basic steps, and we're going to go through each one of those. So as I mentioned, my primary hobby is trying to build this aircraft in my spare time by scratch. And what you're seeing here is I'm currently building a Sonics model Sonics from Sonics aircraft, and they've made some outstanding experimental aircraft. And their Sonics model, you can elect to either get a kit, where they make a lot of all these parts for you, and you kind of finish the parts and put them together. So the parts are kind of already pre-cut, or you can buy basically some really detailed plans. And here you're seeing, I took a photo of one of my plan sheets. You can see it's a little worn because I've been using these plans for a while, but they come out really clean when you get these plans from from Sonics themselves. And you can see these plans are so detailed. I've got all the dimensions I need to draw this part, or even basically as I started this aircraft several years ago, I would take these dimensions and actually just hand draw on the aluminum where I was going to cut, where I was going to drill. And it wasn't only until this past summer that I started messing with CNC routing and drawing these parts in CAD. So these are, you've got all the dimensions you need for the holes are spaced, where all your edges are, where your bends are. You can kind of see this part has some bends to it. It's a rib. And so we can recreate that in CAD. So I'm not going to draw this specific part in CAD, but I want to give you an idea of what I'm starting with. And what, because you can do this with pretty much any type of thing that you're trying to create in metal or wood or plastic, whatever type of material that will work with your router. And so we're going to draw something very similar to this. I'm going to kind of draw a rib that has some holes and some proper dimensions so you get an idea of how you would create this. So this is showing the drawing here, and then next to it you can see this is a 025, 25 mil thick aluminum. This is a part that was cut on the CNC router by me recreating this part. The precision is outstanding in the house. I've been able to get it down to easily within a hundredth of an inch or better on the finished part. This is just kind of a little blow up so you can see where all your type of dimensions are. Really fantastic plans from Sonics. We talked about the first step is really kind of figuring it, drawing this with a computer-aided design package. And I've selected Autodesk Fusion for a few reasons. Fusion has a lot of flexibility. It's a pretty powerful CAD package. Let me back off for a second. There are a lot of choices out there, and when you get to looking at what the CNC router machines are, a lot of the guys that make these CNC router kits, which I'll show you, they have kind of their own software that they'll provide for free that you can use to draw basic parts. And those are great programs. I personally have used CAD in the past quite a bit, and but I also kind of like I wanted to learn a tool that I could do a lot of different things with beyond even aircraft parts, and so it's fairly intuitive to use this. It's very flexible, so very powerful CAD package. So it's a high performance CAD package. The other benefit, you see one environment for CAD and CAM, so I don't have to have, a lot of times people have to use different, one software program to draw the part and another software program to do the motion pass for the tool. I'm going to show you how I can do all that in this one tool. And then the real clincher that Autodesk was smart about is that they make this free for hobbyists, students, and startups, even startup companies. I think, as of today, I think as long as your company doesn't make more than $100,000, you can get the software and use it commercially. I think it's a great model to get people hooked, and then as you start making money, start paying for the software. But it's a free license to use, so that's a pretty nice thing to have, a powerful package that's free. I think some of the other major CAD players are starting to do similar things. I know that when I was at Oshkosh, that I heard that I think SolidWorks offers now a license for EAA members that's free. So I think this is a pretty cool model for software. So we're going to use CAD, Autodesk Fusion. Um, I'll walk you through that. You do have to use one more other software tool. So once we've got our tool pass right, I have to somehow control the machine. And I've selected this universal G-code sender. It's really quite universal. There's many people using this software. It's kind of a community source software. It's free. It gets updated, but it's a pretty cool package to actually take the toolpath and control the machine. Really easy to use. I'll walk through a little bit, but I took some screenshots so you can kind of see here. You can even manually move your machine around with these buttons in the 3 axes. You have buttons here to set your zero on the set your zero on your machine. Very straightforward to use, and there's a large community around it, and a lot of the guys that make the CNCs also are very familiar with the software package as well. And again, I'll just reinforce, I know that like the CNC I'll show you from X-Carve, their software tool does all 3 steps in one software tool. So here I am still using 2 software tools. But you get a little bit more flexibility, I think, by using this tool versus the pre-canned kind of tool that they're developing on their own. You kind of want to go with, my philosophy, I guess, is, AutoCAD's been around for quite some time, so they've really been able to develop their software as opposed to somebody new kind of just building up their own software tool. That's my opinion. All right, so that's a general selection of the tools. So let's now go and draw this part. Okay, so I'm in Autodesk Fusion here. I'll go ahead and get started. I'll mention briefly that I like using English units, fractional units. Makes sense for my aircraft parts. The default is metric. So we'll go ahead and start out by drawing a simple flat rib. We'll start by drawing a rectangle. So we'll create a sketch. If I just press the button R, that should do a rectangle here. We'll do a 4-inch by 10-inch. I go up here and I press this home button, it'll zoom out to show me the whole part. So now I want to go ahead and offset. So I just, you can find offset under the sketch menu or just simply by pressing O. I've got offset on, so I'm going to select this curved offset. One thing I'll point out here, if you have chain selection on and you try to select this, it's going to offset the whole perimeter. So I turn chain selection off so I just get that one wall. I'm going to offset in 1/2 inch for, well, basically I'll cut this part flat, but I'll plan on trying to bend this 1/2 inch up to be the flange for the rib. That's why I'm doing that here. So some of that may not matter to you guys if you're not doing aircraft parts. Do another offset here. Oops. -0.. And let's offset the edges 1 inch. And look like some of the ribs that I make. I'm just pressing O every time I want to offset. Now I'm going to fillet. Now I'm going to try to I'll take the fillet. Sketch. And I'm going to make this curve 1/8 of an inch. You want nice smooth curves, right, in your um, all your bins so you don't have a place that'll create stress in your aircraft part. It's another 1/8 of an inch, and you can see it trimmed off my other uh, part. So let me just go ahead and do this again. So we'll do offset. -1 inch, -0.5 inch. Offset this in -1 inch again. Every time you fillet, it's kind of annoying. Oops, I didn't want the 1.5 inch there. All right, sketch, fillet. So it doesn't have a shortcut fillet. You can add shortcuts, of course, in all these drawing programs. Okay, so now we have our basic part. You can kind of see, and we're basically going to extrude this up. So let me trim off these pieces that we don't need. So I'll hit T or sketch, press T for trim, and I can basically trim these sections off where we're going to need it. So what you're seeing here is kind of this rib that's about 10 inches long, and then we're going to bend this edge up 90 degrees and bend this edge up 90 degrees, and I'll make a nice rib. So the next thing we're going to do, we got our basic part here. I'm going to go ahead and extrude right here, create extrude, and we're going to make it the thickness of the actual metal. In this case, it's 32 mils thick, so 0.032 inches. And now you can kind of see there's thickness to this part, right? So it's a three-dimensional part now. And it's important that we're doing that because then we know where to put our router, where to set the heights for that and everything. Now we're going to go ahead and put some pilot holes in here where we're going to want to match drill. So usually you have some holes in these parts. So I'll show you how we want to place. I want to place about 6 holes on this side that will serve as pilot holes for attaching to the rest to another part of the aircraft. So let's start by sketching an offset. I'm going to select this plane here. So we're going to make another sketch on the top of this object. Understanding sketches is kind of important. Sketches are 2D drawings that you use to as kind of your guideline for making your parts. I don't have a better way of describing it. See if I did that correctly. Now we should have really 2 sketches. Let me get rid of some of this. All right, so sketch. Let's do a new, create a sketch, and we'll create a sketch on this. I'm gonna do, I said create sketch. I'm going to on this top plane. Now our sketch is on this top plane of the object. So you can create a sketch on any side of an object, and then you use that for guidance. This is my sketch. Turns it on. Sketch 1 on the bottom side. I don't really more. But sketch 1, we'll do that here. We're working sketch 1, so I'm selecting it. So I'll do offset. And I'll set this top curve, let's say 1/2 inch in. Let's offset this guy. We'll go in 1 inch. Actually, let's go in 1/2 inch. And we'll do another offset. Select wrong. We'll go in minus 1.5 inches. And we'll offset from this side about. Sketch, offset. We'll go in 1/2 inch. We'll do one more offset. We'll go in 1 inch. All right, so what we're going to do is let's extend these sketch lines out a little bit. We're going to make 6 holes here. So we'll sketch, extend it to the line. So now I got 6 places I want to make holes. So now I'm going to make, I like to make these sketch points where I'm going to have the holes. So you can see these little hairs are going in. And I'm done. Now I've got my little sketch points. So now what we can do back in our object, we'll go ahead and turn this off. It kind of does some funky things. We'll go ahead and now create holes. We'll do a hole. I'll select it right here, and we're going to have a hole that goes down again, 32 mils. And oops, I had it opposite. Yeah, 32 mils, and then the diameter will make it 3/32 of an inch as a pilot hole. It's kind of a standard pilot hole for the Sonics, at least. And I'm going to select all 6 points. See, and it's going to put these holes in for me. Oops, I don't want that. So we changed all the holes at once. So I want a 3/32 diameter hole, and that's it. Now I've got my holes in there. I can turn my sketches off. Yeah, so I've got my nice pilot holes in. Let's assume this is the end of my part. This is my part is drawn. Next, we want to actually go ahead and set it up for CAM. All right, now that we've got our part drawn, let's move into CAM and create our tool paths for cutting this part. So we'll go over here in Fusion and we'll go to CAM. Instead of model, we'll go into CAM mode. And the first thing we're going to do is actually set up what the piece of material is being cut from. So we go to Setup. We'll do a new setup. And this is going to be our piece of material. So you can see this material by default is bigger than the piece that we're creating. We're going to first set up the orientation of our axes. And so I'm going to go ahead and select the axis and plane. So that we simply now, what I've done is I've moved this where this X, Y, and Z is. This will be where our 0 is. And I liked having it in this left corner of my material. And the Z axis, of course, going vertical, Y going forward, and X going this way. That's how I've chosen to do this. And so all the coordinates will be derived from that and create their G code to go to the CNC. So now we've got our orientation. I'm going to have it on the top of the material. Now I'm going to go over to stock, the stock tab, and describe the stock. You know, an easy thing to do is maybe have 1/2 inch around. So you can see 1/2 inch of material around what we're cutting. So this will be material that will cut away. Stock top offset 0. There's really, because this is a 2D part, the material is the exact thickness of what we need to do. So we're really kind of doing 2D cuts here. And then I'll hit OK, and you basically see our material is the same thickness and just basically wider than the part. So we're done. That's our material. Now we're going to start our first cam operation. That will be cutting. So we'll do a 2D contour cut. And now there's a lot of different options on here, and I've already kind of got some things set up the way I want. The main thing is how fast are you going to be cutting, moving horizontally. And 20 inches per minute is kind of what I've derived for cutting through these thin material. And lead in, lead out, feed right. These are how fast you're coming into a cut horizontally. And the plunge rate, how fast you're going down in the material. Remember, we're going to be using a router bit, not a drill bit, so you've got to kind of go in slowly. So I'm just going to use 20 and 1 and 1, and I'll save these settings for you as a link. Now geometry, basically you want to select the contour that we're cutting. I'm going to select this contour here. Now it's going to create this blue path to cut around. And by default, it's going to put tabs. These tabs are where it's going to leave material behind so that it's still attached to the material that you're clamped down. Now, I'll show that in some of the videos in this presentation, but ultimately, I'm not going to have tabs. So now it's going to do a smooth cut all the way around the material. I'm going to elect to hold down the material with clecos in these holes. Usually I'd have clecos in multiple places. So I'm just going to remove the tabs for now, but you can see you could leave tabs there, and those would just be keep outs where the router would be lifted and not cut the material. We'll go to the next thing, height. Heights is important. Heights shows you, and I'm going to kind of rotate this, what height you're going to go to clear before you go to the next cutting operation. So you've kind of got several different heights. You've got clearance height. Let me go ahead and lock this down, okay? And you can highlight over here and see what these are. Clearance height is the first height the tool rapids to on its way to start the tool path. Retract height sets the height that the tool moves up to before the next cutting pass. Should be above the feed height and top. This is a lower, so the clearance height is the top height, right? So almost half an inch. That's where I have the machine rapid to. Now, sometimes I like to set that higher, even an inch above the material, in case I have clecos down so that the router's not running into pieces. Top height, I set to top and bottom height. These settings are important. You can see just 3 mils and maybe 12 mils below the material. And this was important when cutting thicker pieces of material, because if you don't have a perfectly flat surface, you actually want to try to start above the material, because you may, if it's not perfectly level, you don't want to be cutting real deep in one place and not as much in another. So I kind of started above to kind of have a safety zone, and then of course on the bottom you cut lower than the material to make sure you cut all the way through. That can be real important for thicker pieces, because the flat piece we're not going to cut multiple heights. We'll just go around one time and cut it. So passes, the default here is multiple depths for when I do thicker material, where it'll only take away 8 mils at a time. But this is, we're just going to cut one time around the material. So I removed roughing passes. You can have smoothing operations as well. I found that I don't really need that for a thin piece of metal. I can just go one time around the material. And that's it. I'll hit OK. Now we're going to click simulate, and we can actually see the path that it goes on. This is important so you can make sure that if you had some clecos in the way, that the router's not going to cut across and hit something. You don't want it hitting anything, so you want to have a good idea of what's going to happen when you actually go to the CNC. All right, now we're going to add another step and drill these holes, machining step for that. So we'll go drilling, and we'll select our tool, go find our 3/32 drill bit. We'll hit OK, and we'll set our plunge rate, how fast, 10 inches per minute, not too fast. And now we'll come over and select our geometry. Same diameter hole, and if I split one hole, it's going to find all those holes. Pretty cool. You could select each of them at the same individually if you want. We'll hit OK and we're done. And again, you can simulate this and you can see how it's going to hit play. It's going to drill through each of these holes. You know exactly where it's going to go. And we're basically done. So we basically have two different tool paths, the router and then the drill. So now we're ready to create G-code and take it to our tool. So we'll go ahead and hit on this 2D contour, and we'll hit this button up here, Post Process, or you can right click as well. Got Post Process. And one thing I've done on the only thing I've changed on this setting for Fusion is under Properties. I whatever path you had. So I only wanted it to really just retract and stay at the retract height because I don't want it motioning back to 0, 0, 0 on the machine after it's done cutting. So I've unchecked it, as you can see here. Other than that, I don't do anything else. I hit OK. And basically, you want this NC at the name, cut example, .NC. That's exactly what you need. And you hit save. And we're going to highlight now the drill and do the same thing, Post Process. Drill example. And we'll hit save. And what's cool is, let me open that up here. If you double click it, that's basically going to, you open it up in a Word file and you'll see the code. So I'm not going to edit this, I'm just going to leave it alone. I'm going to take it over to my my machine and okay, so I have moved over to my HP netbook that I use as my controller for my CNC. Now I'll show you the CNC in a minute here in slides, but basically this is connected through USB to a little Arduino controller that comes with the CNC. So pretty basic process. I'm connected right now, and if we go to machine control on this universal G-code sender, the first thing I'm going to do is home my machine by pressing *H. It's kind of hard to hear for you, but my machine is now moving to 0 position X, 0 position Y at the highest Z position. That's kind of its homing position. And that'll be the work positions. You'll see down here in a second, these numbers should change to 0. Oh, actually, the machine position is 0, 0, 0, but work position, it's got these negative millimeter numbers. Now, basically, my machine's all the way to the left, all the way to the front, all the way up. I'm going to manually move the machine. I found that I'm going to manually move the machine by pressing -Z, and you can see now the machine position is -25.4. That's millimeters. That's the machine position. What I really care about is my work position. You can see I can change that in a second. I'm going to move over at X an inch or 2, and Y an inch or 2. And I'm basically I'll move down 1 more inch or Z for now. And let's pretend like I basically have centered the router right over that left forwardmost top of the material. And let's pretend that basically it's right there. And then what you're going to do is when I hit reset X, watch the work position number on the left. It goes to 0, reset Y axis, reset Z axis. Now my work position is 0, 0, 0. Machine knows where the top of the material is, that bottom left corner. And we're ready to rock and roll. So now that I've got my machine zeroed out and it's zeroed onto my material, because you're going to want to zero onto your material every time you do a new cut. I'm going to go ahead and load that file. I'm going to load my cut file first. Cut example, this is what I just created. And I'm not going to turn the machine, basically here we would turn the machine on. I'm not going to turn the machine, I would turn the router on, and I would hit send. And the machine is kind of honing in on doing its path. Now the routers, I don't have material on the machine right now because I wanted you to kind of see how this G-code sender works, but it's basically going through that motion path that you saw simulated. I just didn't turn the router on because there's a lot of noise at the moment. So it'll basically run through here, and it'll run through the full motion path of that cut path that we just saw. I'm going to hit cancel, and it'll stop sending the file. And then, if we wanted to hit cancel, it would have finished, and it would have just lifted up, and it would have been done with it. We'd change out the bit, put a drill bit in, and then basically we would have to re-hone in. After we've changed the router bit to a drill bit, we'd have to reset the Z height, right? Because the bit is probably a different length than the router bit. Once we set that, we would go and load the drill file, right, and run that file. It's as simple as that, and then we're basically done. A couple of pointers on this that I've learned is that job complete with error. That's because I hit cancel. If something were to go screwy during the job and starts to go off path, you can hit this. There's a help button. Actually, you see this. It do some of the stuff. I really love using the number pad to manually move X and Y and Z. A number pad, a keypad on your keyboard, because it makes it a lot more intuitive than trying to mouse over to these buttons. And if something goes wrong, you can hit a soft reset, and it will stop moving it'll pause the machine, right? So that it doesn't screw up on the position. Like for some reason you get an interruption of communication or something, soft reset is a nice button. And that's basically it. I know it's very basic, but just so that you get a basic understanding of how the universal G-code sender works.
All right, so that was fun. We got to go through the tools. Quick tour through the tools. Now let's talk about the machine. I showed drawing and even controlling the machine, but I haven't told you anything about the machine that I'm using. So selecting a CNC router is there are a lot of choices. There are a lot of options out there. I'm going to go through why I've selected the X-Carve from Invendables, because it's a pretty good machine for what I'm trying to do. So the CNC router I got, is basically all in. I was about $1,500, including the DeWalt router, and it was. This is based on the Shapeoko, and they've really learned a lot and continue to improve this machine. It supported the universal G-coder sender support. There's a great community, and I can cut aluminum with it. So that's basically why I've selected this machine. Oh, and the big workspace was also pretty nice. And the fact that initially I thought that maybe I might scale the machine. You could actually get bigger slides and make the machine bigger if you'd like. I'm not going to do that now, but that's something I thought I might do initially. So things to consider when you have a CNC like this, that as a maker CNC, I'll call it, versus a commercial or an industrial CNC, really has to do with rigidity. I mean, these are maker slides, and it's not quite as rigid that you might get in, if you put a lot of pressure and you're trying to drill into something really tough, really fast. There will be some pressure put on these slides. We call them maker slides, but the main cross beams here, these are roughly 1 inch by 2 inch in diameter, and not quite as, some industrial CNCs, you might see it like a 6-inch I-beam or something for some of these slides. Um, it's definitely useful for cutting into aluminum. You just have to know these things about it so that you're not putting too much pressure on the machine at any time. So really about rigidity, and that really applies to any of the maker CNCs I can see out there. That really has a lot to do with it. So one thing that's scary about, and probably why maybe you're watching this video, is, hey, how fast do I turn the spindle? How fast do I move the router, et cetera. And I found that the speed and feed calculators didn't really apply as much because of the rigidity of the machine, and also the fact that I was playing with very thin aluminum most of the time. Um, so, the other thing too here is that aluminum, you usually want to be cutting slower, but getting an off-the-shelf hand router, that's not something. Um, it's going to be cutting faster, and that's what you're limited to. The slowest speed being like 17,000 RPM. So I kind of those didn't really work too well, and I started leaning on the support community, and then playing with the tool itself to find things that work the best. Um, Began with test pieces. I started with this kind of a straight flute bit, which I've learned was not the ideal bit for what I was trying to do. And these are kind of the sample settings, 20 inches per minute cutting, horizontally, uh, and a depth of cut of about 10 mils, 0.01 inches. All right, so um, first thing I like to do is do like a test piece. That's what I learned, how to refine kind of the speeds and everything. So what you're seeing here, I'm using my standard straight flute router bit, and I'm trying to cut a 3-inch square that I drew up in CAD. And you can see right now it's not even actually on the material on this left side because my workspace is not perfectly flat, and I fix that later. That's pretty. You can see it's digging in. It's at the same height right now that it was a while ago. It's digging in there because that backside is not being clamped down, so that this thin material is actually lifting up. It's not that my workspace isn't flat, but this thin material is going to bow and flex depending on how you have it clamped down. You see where it's clamped down right here, see the bit's not touching again because the clamp down is holding the material down lower. And again, remember, it's very thin material, 0.025. And so initially I would cut several heights, and I'd step down about 0.008 inches or 8 mils at a time. So this workspace kind of helped me kind of refine the speeds that I was cutting at. And I used this with this bit, and then eventually I changed bits. As you'll see in a little bit, I went to a different bit and I was able to cut all the way through material. But this allowed me to see, like, as it was plunging into the material, if there was too much pressure being applied, and the bit would walk a little bit. So I could always test things out here. It does circles pretty well. Look at that lift. You see it lifting? So this was a clear lesson that I learned. I was using a different bit here, but you've got to know where that router is going. How many times is it doing that circle when it's moving? And basically, you really want to stay clear of the router at all times. There's the nasty picture of that finger, and luckily it healed back. It cut all the way through that fingernail, but the fingernail grew back out. I lost a little bit of, even the tip of the fingernail filled back in. The flesh did. The fingerprint looks a little weird now. Some of the flesh is slightly different, but it basically looks normal. Tough lesson to learn, but so always know. Really try to avoid placing your hands near the router. I mean, this thing is spinning incredibly fast. Router is going to cut through your your fingers. It's going to cut through bone even. You know, it's cutting through. It can cut through this material pretty easily. So be careful. Of course, wear eye, ear, and breathing protection. So eye and ear protection, I think everybody kind of hears about, but especially with aluminum and wood, this thing is cutting at 20,000 RPM. It's putting up very small pieces of material, and so I started wearing this breathing apparatus when I was near it while it's cutting. Particularly, usually I'm cutting through some sort of wood underneath, like an MDF, and so it creates a very small particle dust. And I don't know if you've used this one pictured before, but these are about $30, $40 at a Home Depot or a Lowe's or something like that, and they fit incredibly comfortably. It was totally worth the $30. I've always used those kind of paper masks, and those things are uncomfortable to wear. But this thing, it will allow you to breathe easily in your glasses when it fog up or whatnot, and it's blocking everything from coming in. So it's worth the investment. Be prepared to kill the power on the machine. You saw a picture of me, probably the worst, video of me cutting through my hand. But I've also been out there when I forgot where the router was going to go after it got done with the piece, and it ran into another piece, like one of my temporary Clecos that you'll see, and sparks are flying, that sort of thing. Or maybe it starts burning up on the wood. The wood starts catching on fire, that sort of thing. So you can't let this thing just sit there and walk away. You've got to be present while the machine's running and be ready to kill the power. So can't stress that enough. Oh, that's the last point. Yeah, basically, don't babysit that machine. All right, so just some initial videos. Here are some of the things that were lessons, because we're working with thin aluminum here, 25, 32 mils thick. You can see some of the way I clamp down the material. The X-Carve comes with these cool clamps you can get in kits. This worked fairly well, but in between, even these 4 or 5 inch spans, the material would lift, and it wouldn't keep the material completely flat. And I tried, these are Clecos. Those are the aircraft builders out there will know what these are. These are temporary holders that go into holes that you would drill. And that was useful. But really what I found even was just using a safety block, a piece of wood to hold down the material as the router is cutting, was very useful. Biggest issues that we overcome, lessons learned, is just the heat generated by cutting through this metal, especially without using lubrication. So I could use lubricant. It's super messy. You have to have ventilation for cutting fluid. I didn't want to mess with lubricant long term, so I've got away from that and got away from the heat issues. The solution I have is using this Viper end mill bit. This is kind of a blown up image from Destiny Tool. This was something I was led on to by another member on the Inventables forum. And this bit is fantastic for cutting through aluminum. I was able to, instead of just taking 10 mils off of that skin at a time, I cut through the whole skin at one time, one depth. I don't have to go multiple depths. And the material is much cooler when it cuts through there, so it keeps the chips flying away. So you want that kind of, I found that to be very useful. I've already been talking about this a little bit, the flex of the axis as you're plunging into material. So here you can kind of see as the router would come down in the material, it would have, it couldn't go all the way through it, so it would flex and move into, it's cutting, and here's my part that I'm trying to keep on the right. It moved in instead of keeping that nice line. So an issue to overcome is a really slow plunge rate, but also try to plunge away from the material that you're cutting. That's the other, so a horizontal lead in is what I'm trying to say, is plunge over here and then come over to the right to the material. So you don't have, because once you're in the material, you're cutting through it, there's not going to be this play in the Z-axis. Hope that makes sense. So now let's look at drilling. Cutting is one thing, but we also need a drill for these aircraft parts. So here you can see I'm using a 3/32 inch bit and drilling some basic holes. I want to give you an idea of that drilling step and what that looks like. And we'll talk about some of the lessons learned here in a second, but this is using a standard drill bit and basically going at the slowest speed on the router for that. And part of the initial issue here with drilling is that I had quite a bit of wobble with this long bit and getting it to drill a precise hole like you would with a normal drill press or even a handheld drill. So overcoming that waddle, I use this first this chuck adapter, right? You have to use that. This is a quarter-inch adapter to put in small drill bits because a router is not a drill, so you can't just clamp it down to any size. It only has one size, quarter-inch diameter. And then I actually cut the drill bit to shorten the length of the drill bit so it doesn't wobble. You cut the drill bit in half basically, and it'll still clamp in here and work because I'm not drilling that deep of holes. And then the other thing I do, you didn't see in that video, but I start applying pressure with my hand on the router as it's drilling into the material. By applying that pressure, it keeps it from the drill bit from starting to go out one axis because there's a little bit of flex in that y-axis. So it's just a little help it go into the material initially, and then you can release the pressure. You kind of get a feel for it. How fast to run the spindle? So ideally you run the spindle speed, how fast the bit's moving, as slow as possible without it causing it to walk. Meaning if it's going too slow, then it's not cutting away material fast enough and there's more pressure being applied to the router. I found the setting of 2 or 3 worked really well on the, which is about 20,000 RPM, worked really well. A setting of 1, the slowest speed possible for drilling, that's 17,000 RPM. That's much faster than you normally would drill, is what I use for drilling. So now let's just put that all together on a rib. Here we're still using the standard drill bit length, so I'll show that later with the cut drill bit like we talked about. But here we're going to drill a bunch of holes. You see the video is kind of sped up. And initially here I've clamped down a bunch of these tall clecos on the outside, right, to hold down the material. I'm using my new bit, and this is where I learned that I did several height cuts, but I found that with this new bit and these speeds, it could actually cut through the material all at one time, this thin material. So I learned that I really don't have to do multiple heights with this bit. By putting this all together, you've got a pretty nice part that just needs a little bit of polishing on, with the sander at the end, a polishing belt. And I keep my hand out of the way of the router. It just cuts through that hole. It's doing multiple heights again, but didn't need it. So here we're doing a thicker part as the screen was displayed. We start off by drilling, and it's doing a peck drill process where it's using that shorter drill bit we talked about, but it's drilling in a little bit of depth and then retracting to remove the aluminum chips. This is 3/16 inch thick aluminum, so much thicker. So this will produce a really nice hole. You just have to slightly deburr at the end on both sides, and that's about it. So here we just speed up the video a little bit so you can see it drill my multiple holes with that pecking process. Pretty manageable process. So now we finished the drilling step, and this is an important thing to show because we've talked about it earlier, but basically I'm going to retract on the Z-axis, remove the bit, and replace it with my router bit. And once that's done, we'll put the new bit in and actually bring the router back down to the top of the material and reset the Z-axis height to 0 in the G-code universal sender router, right? We'll bring that height down, set our new Z height, and then start our next cutting process.
And essentially there we have it. We have the new Z height for the router. And for the sake of this long class, I've cut out some portions of the video here, but this full video is also on YouTube and on the website, so you can see the start to finish of doing this part. But here we're putting in these cool clecos. You see that we squeeze the cleco and it's set for this whole size, and then it expands as you put it in there. It's going to hold the material down so that we can go and cut this whole part without any keep out tabs. So that makes it pretty cool. So we've started the router back up. It's doing its path. And you can see, again, it's important to reinforce here. We don't want to just dig deep into the material this first time, especially with the thicker material. So it's doing a pass. You can see it's just now tapping the material in the back end there, right? So I'm not perfectly level on this workspace. You can certainly spend time and get your workspace perfectly level, but basically between those two steps is only 10 mils difference. So I only have 10 mils of height difference. So I'm pretty flat. I'm just not perfectly flat. So that first pass, we barely tapped it. And the second pass is definitely cutting into the material all the way around. It's getting a nice, smooth pass all the way around. And you can see it comes out a little bit and then plunges away from the final material, then comes into it. And it's doing a nice job of keeping the material pretty cool. It's not too hot and not too much pressure on the machine. So it can actually cut. It's going to do about 30 passes here. You'll see it go real fast now. Okay, so it's basically finished, and now I've changed out to a third bit on this part, and that's a chamfer 45-degree chamfer bit. So we're actually doing a third pass on this particular part. Just wanted to say you're not limited to just drilling and cutting, obviously. Again, for those of you new to this, on a CNC, there are lots of different types of bits you can use. And this is just going to put a nice little 45-degree chamfer on that edge, because it has to, the way it's going to mate up in the final assembly. It's doing 2 passes. It's going to cut another little bit off. And now we're done. We have a part that's just needs to be a little bit deburred and polished off with the sander. No lubrication. So now that I've played with it, I have some new settings. These are kind of my key guidelines that I would use. And you could pause the video here if you want and jot these down. But these are my key numbers that I used for cutting skins, thin material, and then thicker stock on the right side. I hit this earlier, so one thing I did for the G-code generation is I made sure I don't jog home, and I retract to the Z height, so that's something about. And that concludes the session. So next is, how do I make a big airplane skin? So I'm going to do that in the next video. You'll see this tiling video, and here you see 100 times speed up, and I'm drilling and routing almost nearly 10-foot long skin. And you can see I've taken my machine and put it on top of the aluminum that I'm cutting. And we'll go through the steps on how to do this in the drawing programs, how to kind of set it up so that it's calibrated across multiple passes. So I encourage you to watch the next video. If you have any questions about this video, feel free to send me questions. Happy to do my best to answer them. So thanks for watching.